Attention! Hello, everybody! It is 4:33 p.m. on the 21st of January, 2017. And guys, oh man, here's the way it goes. I always come under severe attack, and then within a few days of coming under severe attack, the biggest breakthrough, confirmation, something comes out that just totally supports what I do. And this is the way it's happened. It's happened this way several times over the past several weeks and months. That when I do get attacked, take a look at the screen here, guys. Take a look at the screen. We are over here on Business Insider, but this is a story breaking across a lot of media right now. Listen to this. This is today, 11 hours ago. A discovery about the movement of tectonic plates will have scientists rewriting the textbooks. Now listen to this. Look at the graphic they're using. They're using the NOAA graphic, the original version of what's on Earthquake 3D right now. This graphic right here, see where it says NOAA? This is my original Earthquake 3D graphic. It is. So let me just read this to you. Plate tectonics is the widely accepted theory that the Earth's crust is divided into several sections that float around on the mantle. The mostly solid layer between the core and the crust. But how they move around has been a subject of much debate among scientists since the theory was first accepted in the 1950s. The sections, known as plates, move at a rate about 2 to 5 centimeters per year, which is a similar speed to how fast your fingernails grow. When they grind past each other, it's called a transform plate boundary, which can cause earthquakes. When they move away from each other, it's known as a divergent boundary, where lava spews out and volcanoes can form. Sometimes, when they meet each other head-on, one plate starts moving upwards to form mountains, while the other is pushed downwards where it melts. This is a convergent boundary. Scientists have wondered for many decades whether the plates are being passively moved around by the mantle, or are they active drivers for movement themselves, dragging the mantle around with them. Now listen to this, guys. Listen. A new study published in the Journal of Science Advances has shown the additional force of heat drawn from the Earth's core plays a part in plate dynamics. The team observed in the East Pacific Rise, which is a divergent tectonic plate boundary which lies along the Pacific Ocean floor, and also made models of the mantle flow beneath the surface. During their observations, they concluded that the movement of the East Pacific Rise could not be completely explained by subduction, when one plate moves under the other, and other forces had to be at play. In the paper, they state that the buoyancy is created by heat rising up from deep within the Earth's core. The estimate is 50% of plate tectonic movement is driven by this heat coming up from the core. About 20 terawatts of heat flows between the core and the mantle. That's just slightly more than the average total of power consumption by humans on Earth every year. And that's every second. Okay? So everything that humans use every year is flowing every second through the mantle. We see strong support for significant deep mantle contributions of heat to plate dynamics in the Pacific Hemisphere, said Professor David B. Rowley, an expert of geophysical sciences at the University of Chicago and the lead author of the paper. In a statement, quote, "Heat from the base of the mantle contributes significantly to the strength of flow of heat in the mantle and to the resultant plate tectonics. When the case on the mantle is heated, this reduces the density of the material, making it buoyant, which causes it to rise through the mantle." There's our deep earthquakes, guys. Plates also cool at the surface, creating something called negative buoyancy, which is another way of describing an object that sinks. These two forces move the plates around. In other words, hot parts rise, cool parts sink, creating a sort of churning movement in the mantle that the plates ride on. Quote, "Based upon our models of mantle convection, the mantle may be removing as much as half of the Earth's total convective heat budget from the core." In other words, dissipating half the heat from the core comes up and goes all the way out to the mantle into the plates. The implication of our work is that textbooks will need to be rewritten. Okay? So, everything I've discovered in the last 7 years has now been confirmed and done in a paper, and they need to rewrite the textbook. Gee, didn't I say that we were going to need to rewrite the textbook? We were tearing out whole sections and replacing it with what we found here in the Pacific about deep earthquakes causing shallow earthquakes, about pressure coming up from the core through the mantle hitting the bottom of the plates, what was causing it, what was the driver. Now, here it is. What can I say, guys? This is phenomenal. This is probably this is like the day that I found out that they confirmed fracking earthquakes.
2.0.
Okay, so, for a long time people denied fracking earthquakes, and then we found out it came out and the studies were confirming it. Now the studies are confirming everything I told you about deep earthquakes coming up from the core, causing a main driver of the pushing of the plates, and now it's fully been studied. Fully been studied. Oh, and you know what? Really quick, just while I've got you on here, let's just quickly go look up and see where the East Pacific Rise is. Now, I already know this, but you guys may not, so let's get back over here. Let's go look up East Pacific Rise. Okay, East Pacific Rise. This is amazing, man. Amazing. Okay, East Pacific Rise, right south of Mexico. There we go, guys. Hey, how about this, by the way? The East Pacific Rise south of Mexico, where were they doing those studies, guys, for earthquakes down in the asthenosphere? Remember? Off the coast of Mexico? Well, here we are. They were doing the experiments down on the coast, off the coast of Mexico, for a good reason. Here's the East Pacific Rise. This is the main pusher where they said it's not subduction. I knew it. I knew it. Subduction is not taking place. Just as I told you. Subduction cannot account for it. And if somebody went back to review it to see if we were right. I mean, I've been talking about this for 2 years at this point. That there is no subduction going on the West Coast. It cannot explain what's going on with the buoyancy of the plate and the rise. Which means that the heat is technically the pressure coming up from the core translated through heat. You heard it, 20 terawatts every second, 20 terawatts constant. And that's what humans use every day around the planet, being expended every second from the core coming up to the plates. You think that's going to cause earthquakes? Think that's going to cause movement? Sure does. So I'm positive now. Somebody somewhere watch look. A 50-year-old concept now fully dethroned within a few months of me raising it. Come on. So it is what it is. You'll never get credit if you do something on YouTube, but you guys know it. I know it. You know it. Any longtime viewer, you know it. That we were the ones who brought it out. They were the ones who watched it. They went to go prove it. That's what happened. Just plain as day. So we proposed it. Someone else questioned it, said, you know what, let's go out and study that and see what happens. And then they went out and did it and found out. And now it's proved. So everything I told you is now proved. And I'm going to put a link down below. I'm going to save this as a video on my channel because this is ultimate vindication. Hey, you think they're going to give me credit over on the website they just created against me, guys? They're going to put a big old thing up top and say, hey, look, Dutchsinse was proved right about everything he ever said. It kind of doesn't matter whether or not I got an earthquake forecast right or not now, guys. Something much greater has been proved. Something much greater has been proved. We disproved plate tectonics and subduction. I'd say that's almost as big. That's as big as finding Mount Dutch supervolcano at the North Pole, and it's as big as discovering fracking earthquakes are a serious problem back in 2010 when everybody else denied it. We have been on the cutting edge, the vanguard cutting edge of geology for the last several years. And they are taking my stuff and going to prove it. All right, so word up, guys. Much love. Have a plan. Be prepared just in case. I don't care if anybody doesn't believe me. Seriously, go ahead and take me to task if you don't believe that they're copying what I'm talking about. I don't care if you believe me. I'm telling you. That's what I believe. And if you want to try and contradict it, so be it. You guys can think whatever you want. But I'm telling you, they are listening and taking the work and copying it. It's happened too many times at this point. Paper-thin battery, asthenosphere earthquakes, just pretty much everything that I've ever talked about. And they always wait. I mean, it takes them a while to go prove it because they hear what I'm talking about. I say somebody needs to go do it and prove it, da-da-da-da-da. Then a scientist says, you know what, I'm going to go get my research financing for this, and I'm going to go do it. And then they went and did it, and they go prove it, just as we were expecting. And now, again, I raised this point for the last several years, talking about how subduction can't be taking place along the East Pacific Rise. I brought up the East Pacific Rise. I talked about it at length, talked about off the coast of Mexico, where we have our second Z-shaped fracture. Right here, we have a Z-shaped fracture here. We have another Z-shaped fracture up here at the Juan de Fuca fracture zone off the coast of the U.S. And the East Pacific Rise, I talked about this. California rising out of the sea. Yes, technically the plates are sinking, but when you talk about the plates sinking, it's being constantly regenerated, renewed by upwelling pressure coming up and hardening on the bottom of the plate. So while some parts are breaking off, the other parts are going on. That's what's giving our earthquake progression across the underside of the plate, going across the plate. And that will be proved in the next few years. You watch. You watch. Someone will come out and do asthenosphere studies to find out that at 5 kilometers down below the plate, right where the plate meets the asthenosphere, we are starting to see break-offs occur, and then those spots that break off refill back up with magma and harden like a scab on the underside of the plate. And they'll find that's happening across North America and Central America and South America soon. I probably would venture a good guess. And then they'll also find out that subduction's not taking place off the West Coast at all. One plate, the United States does not, or Pacific plate does not bend underneath the U.S. at all. And that the buoyancy that's created and the plate rise that's happening is coming from force, coming from, literally, from pushing across the Pacific and impacting the coast, pushing it upwards. The threat of California falling into the ocean would never happen because California is being pushed up. Okay? Yeah, so, bravo, bravo. All right, we got it, guys. And now seeing an article like this today just makes my day. I'm going to say this is a video. We're going to call it, well, I'll come up with a creative title for it, and I'll save it over on my YouTube channel, okay? So have a plan, be prepared. I'll be back in a little while, guys. Much love.